Today's lesson is called Solving Basic One-Variable Quadratic Equations, Day 2. We'll start with example 1. Lord Byron is designing a set of square garden plots so some peasant families in his kingdom can grow vegetables. He has enough land to make as many gardens of whatever size he wishes. The minimum size for a plot recommended for vegetable gardening is at least 2 meters on each side. Lord Byron has enough space around the castle to make bigger plots. He decides that one side will be the minimum of 2 meters plus an as yet undecided length x. So in question A, what expression can represent the area of one individual garden based on the undecided additional length? So originally we would have been at 2 by 2, but we have this additional length that we're not sure of that we're going to add to it. So that's going to make our expression x plus 2 times x plus 2. Or, instead, you can write that as x plus 2 in parentheses squared, since it's x plus 2 times itself. So a way to look at this is that you started out with kind of a 2 by 2 square. But then when you add the extra additional amount, it kind of turns it into this 4 square multiplication of binomials that we've talked about before. So you have your x plus 2 and your x plus 2. All right, in question B, it says there are 12 families in the kingdom who are interested in growing vegetables in the gardens. What equation can represent the total area A of the 12 gardens? Well, question A was the area, remember, of one individual garden. So we know for sure that that's going to be x plus 2 times x plus 2 or x plus 2 squared. But now we have 12 different families, so we need 12 of those. So our area is going to be 12 times that x plus 2 quantity squared, so that 12 people have each one of those area plots. Now in question C, it says if the total area available for the gardens is 300 square meters, what are the dimensions of each garden? So now they're telling us that the area is 300. So in our equation above, A equals 12 times x plus 2 quantity squared, we can replace the A with 300. Now we're going to be learning a new method of solving today that's related to what we did in the previous lesson. So we're going to keep it set up like this, where we're going to have the squared on one side and the numbers on the other. We do need to, though, isolate that x plus 2 squared by getting rid of the 12. So we're going to divide both sides by 12, and we get 25 equals, this is x plus 2 quantity squared. Now, because the whole quantity is squared, we have technically isolated the squared part of this equation. So we can jump in now to taking the square root of both sides. So I'm going to rewrite this on the other side just so that we have a nice neat for our notes. So right now we have this equation. We are going to take the square root of both sides. So when we take the square root of 25, remember that's a positive and a negative 5. And if you take the square root of x plus 2, the quantity squared, you just get x plus 2. So we have two equations that we're going to solve. We're going to solve 5 equals x plus 2 and negative 5 equals x plus 2, since the square root of 25 is positive and negative 5. So we will subtract 2 and get x equals 3. On this side, we will subtract 2 and get x equals negative 7. But remember that this question is talking about the dimensions of a garden. So we're going to keep that in mind, knowing that we probably shouldn't use the negative then. So we're going to slash this and reject it. And now we know that x equals 3 is the value that we want to use. It said what are the dimensions of each garden. So careful. Our x value is a 3, but remember our dimension is technically x plus 2, which means 3 plus 2, which means 5. So the gardens will be 5 meters by 5 meters. Now in D, it says find both values of x that make the equation true, the solution set. What value of x will Lord Byron need to add to the 2 meters? So we've kind of already answered this, but we will add it underneath. Technically, the way that you would write this solution set would be x equals, and you would list your x values. However, we just discussed that Lord Byron would use the positive value because of what the problem is about. Now moving on to example 2, we're going to solve each equation. Some of them may have radicals in their solutions. So we want to look at this new type of solving where we have a quantity squared. We'll start with the one on the left, number 1, x minus 3 squared equals 1. Since the squared is already isolated, we can jump right into taking the square root. So I'm going to take the square root of this side and of this side. So I get x minus 3, because the square root of x minus 3 squared is just x minus 3, and the square root of 1 is positive and negative 1. So I'm going to split that and solve each piece. I'm going to solve x minus 3 equals 1 and x minus 3 equals negative 1. Here I add 3 to both sides and get x equals 4. Here I add 3 to both sides and get x equals 2. So my answer is x equals the list 2, 4. I have 2 x values that I have there. In number 2, the x minus 3 squared is not isolated, so I have to do that first. I need to get rid of that 2 by dividing both sides by 2. So I get x minus 3 squared equals 6. So now I'm going to take the square root of both sides. So I get x minus 3 equals, now the square root of 6, 6 is not a perfect square, so we're going to leave it as square root 6 since it's an irrational number, but I still need the positive and negative out front. So positive and negative square root of 6. So for this type of equation, we just need to move the 3 to the other side. So we're going to add 3 to both sides and get x equals 3 plus or minus the square root of 6. And that's our answer for the middle one. When we look at number 3, we've got 4 times the quantity x minus 3 squared equals 1. So here again, we've got to isolate the squared, so we're going to have to divide both sides by 4 to get x minus 3 squared equals 1/4. We're going to take the square root of both sides and get x minus 3 equals, the square root of 1 is 1, the square root of 4 is 2, and remember we need our plus or minus when we take a square root. So we have 2 equations to solve. X minus 3 equals 1/2, and x minus 3 equals negative 1/2. So we'd add 3. We get x equals 3.5. Here when we add 3, on the other side, we get x equals 2.5. So our answer is x equals 2.5 and 3.5. So now in number 4, it says analyze the solutions for exercises 1 through 3. Notice how the questions all had x minus 3 squared as a factor, but each solution was different. So we got either a radical, a mixed number, or a whole number, and we're going to explain how the structure of each expression affected each problem's solution pair. So let's look at example 1 first. Well, number 1 in example 2. Okay, out of radical, mixed number, and whole number, this is our example that ended in a whole number. Now, why did it end in a whole number? We had x minus 3 squared, and it was equal, so was equal to a, well, let's see what it was equal to. 1 is a whole number perfect square. So it was a whole number because that was equal to a whole number perfect square. So anytime that happens, you're going to get a whole number type of answer. If we look at number 2 under example 2, our answer ended in a radical. That's because our x minus 3 squared was equal to a non-perfect square. So anytime that happens, when you have it equal to a non-perfect square, you're going to have a radical as part of your answer. And then lastly, in number 3, under example 2, that answer ended up in a mixed number. And that's because the x minus 3 squared was equal to, let's see what it was equal to. We ended up with 1/4 once we simplified it. So that is a perfect square fraction. So it was equal to a fractional perfect square. Okay. Now, if your teacher has practice that they've given to you separate, you are done with the notes and you can go do that activity. If your teacher would like you to do the practice within the notes, please pause the video, try the practice activity, and then resume when you are done. Okay, now that you've had time to try the practice problems, it said before solving equations A through C, which of the following will result in a whole number solution, a mixed number solution, and a radical? So you had to make your predictions first based on their setup and then solve to see if you were correct. So it should have been whole number is A, mixed number is C, radical is B. Because in A, it was equal to a whole number perfect square. So you got answers of -1 and 5. In B, it ended up equal to a non-perfect square. So that's why you added up with radical answers. And just a special note about that one, you can leave it as x equals 2 plus or minus the square root of 3, but you also can write it in the set notation like the others. I did not do that earlier in the lesson, but you can see it here in the practice. I could choose to write it as 2 plus square root 3, comma, 2 minus square root 3. Either one is acceptable. And then in C, because it was equal to a fractional perfect square, you ended up with a mixed number. So you ended up with -1.5 and -0.5. And that concludes your lesson on solving basic one-variable quadratic equations, day 2.